Let's get to the maybe the most important, most used rules that you will use in this course as far as differentiation goes. So the first one is the product rule. And so we use this when we have a product. So we have a product of two functions. We'll call them u of x times v of x. And so if we want to take the derivative of this function, so for example, we'll learn the product or the derivative of e to the x at some point. But if we wanted to find the derivative of this function x squared e to the x, this is the formula that we will use. So u prime and v prime both exist. Then we have f prime of x equals u of x times v prime of x plus v of x times u prime of x. So we're just essentially we are holding one function as a constant. We're not changing it at all. And we're going to multiply that first function by the derivative of the second function. And then we're going to add the opposite. So in the second term, we leave the second function alone and we take the derivative of the first function. So very basic formula. Obviously, since we're adding, it doesn't matter the order that you hold one and take the derivative of the other. You can do either one, so it doesn't matter. So let's look at an example. So we have a product of x cubed plus 7 and 4 minus x squared. Now, you could multiply this out. You could just FOIL this out. This would not be a big deal to do. But it's easier, and in most cases, this case maybe is the same. Probably doesn't matter. But you could FOIL this out and then just take the derivative term by term. But let's use the product rule. So let's find y prime. So we'll let u of x be x cubed plus 7. We'll let v of x be 4 minus x squared. And so we can write u prime of x is 3x squared, and v prime of x is negative 2x. And so we'll move this down a little bit so we're not too cluttered. So u of x is x cubed plus 7 times v prime, which is negative 2x, plus v of x, which is 4 minus x squared. Be careful with the parentheses. Don't leave the parentheses off on here because it's just plus 4 minus x squared and then multiply by something, you'll mess up. Times u prime of x is 3x squared. Now, once you get this formula down, this is you're probably good, and then you may make a mistake if you're not careful. So be careful with simplifying. So let's distribute the negative 2x. So we get negative 2x to the fourth minus 14x. Distribute the 3x squared. We get plus 12x squared minus 3x to the fourth. And combine your like terms, we get negative 5x to the fourth minus 14x plus 12x squared. And then that is our derivative. Okay, so pretty easy formula. Use it enough to where you can easily do it. If you need to, write the formula out before you apply it. That might also help. But we should use this formula enough throughout this semester that you won't need to try too hard to memorize it. You will memorize it just from all the practice that we're going to get. The next one is the quotient rule. So this one, of course, is where you have a quotient of two functions. They can be any functions that are differentiable. If you want to take the derivative of this one is a little bit more complex. So we have the bottom function times the derivative of the top function. So v of x times u prime of x minus the top function times the derivative of the bottom function. So now, so far, it kind of looks like the product rule, except we're subtracting. But now we're going to divide by the bottom function, not the derivative, just the bottom function, squared. So this one, of course, we're subtracting. So the order that you're doing this numerator does matter. You need to take the derivative of the top function first. and then the derivative of the bottom function second. So the way I remembered this, I still remember in high school, we called this bottom function the low function, the top function the high function. And so it's the low function times the derivative of the high function minus the high function times the derivative of the low function, all over the low function squared. So every time I do this, I will say low d high minus high d low over low low, or low squared. You could say that too. But however you remember how to do it, make sure you remember how to do it. That's the important thing. However you need to do it, you can do it. This is just f of x. So again, very important formula. We'll use this all the time going forward. So make sure you're doing enough of these to get some practice. All right, so we want to find the derivative of 3x plus 2 over 5 minus 2x. So u is 3x plus 2. V is 5 minus 2x. So let's find u prime would be 3. V prime would be negative 2. And so let's find f prime of x. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Now we're going to simplify, and when you simplify, you probably don't even need to worry about anything with the denominator. The only time you will have to worry about that is if maybe you have some negative exponent up here or down here, maybe 3x to the negative 1. And then you take the derivative and say you have a fraction in the numerator up here that you have to incorporate into the denominator, and then the simplification gets a little bit messier. But generally speaking, if you just have something like this, simplify the top, don't really worry about doing anything to the bottom. So let's distribute the 3. So 15 minus 6x, distribute the negative 2. So we have plus 6x plus 4 over 5 minus 2x squared. And so the 6x's cancel, and then 15 plus 4 is 19. And there's our final answer. All right, so these are not too complicated. Again, if you do 3 or 4 of these, you should be good. Now, on the homework, if you don't get enough practice on the homework, just regenerate the question and do it again, and do it again with different numbers. And you can definitely get enough practice from the homework if you redo it some, but do it as much as you need to, because again, these are going to come up for the rest of the time that we're together. All right, next, so this is kind of an application, marginal average cost. So whenever you see marginal, think derivative. So if you find the marginal cost, you're going to have to find the derivative of something. So if the total cost to manufacture X item is given by a cost function C of X, then the average cost per item will denote this C bar of X, and you're just going to divide your cost function by X. And then the marginal average cost is the derivative of this C bar of X. So if we have the total cost in hundreds of dollars to produce X units of perfume, where we have 5x minus 2 over 9x plus 1, find the average cost function. So that's C bar of X equals C of X over X. So essentially, we're just multiplying this denominator by X. So we have 5x minus 2 over 9x squared plus X. So there's our average cost function. Now let's find the marginal average cost function. So we're going to take the derivative of this C bar of X. So this will be the bottom times the derivative of the top minus the top times the derivative of the bottom, all over bottom squared. Now let's simplify the top. So we have 45x squared plus 5x. And then we'll FOIL this. So we get 90x squared plus 5x minus 36x minus 2 all over 9x squared plus x squared. And then we have 45x squared minus 90x squared. So that will be negative 45x squared. 5x minus 5x, that goes away, plus 36x. And then plus 2 all over 9x squared plus x squared. So there is our marginal average cost. And then the last part, we're going to find average cost for production level of 35 units. So we're going to find C bar of 35. Erase that. 35. So you just plug 35 in here. So 5 times 35 minus 2 over 9 times 35 squared plus 35. And let's see what we get. Uh, 0.0156. Now, this is in hundreds of dollars. So that gives us $1.56. Then let's find the marginal average cost at 35 units. So plug 35 into our derivative. So negative 45 times 35 squared plus 36 times 35 plus 2 all over 9 times 35 squared plus 35, all of that squared. And let's see what we get. So we get negative 0.00044. Let's multiply that by 100 to figure out the cost in dollars, and that will be negative 4 cents. We'll put $1 there. Okay, so there you go. So again, product and quotient rule, very important as we go forward. Make sure you're practicing, make sure you learn that formula, those two formulas. Learn these. We'll see this application come up somewhat throughout the semester as well. But the product rule, the quotient rule, maybe the two most important things we're going to do this semester.